Hello, everyone.
Yeah, the UDP based one.
Tell you more about that.
Sure.
Sorry to interrupt. Yeah, so my name's Troy Miller. I'm the product manager for the API team at UShip. Kind of filling in for Jason Harmon here today. This is the API meetup. Some of you guys are new, welcome. You'll find out that we have a wide variety of folks here who are from product managers, developers, business analysts, across the board. So everyone's welcome, tell your friends, come on down. Today we have Paul Frazee,
Frazee.
thank you very much, who's going to be discussing decentralized servers and all the goodness that comes with that. After this is done, we'll have basically a time to go around the room, introduce yourselves, and if you guys have any job openings or want to give out any leads or anything like that, just kind of save them for later and we'll go through all that. So without further ado, Paul.
Okay, bear with me everybody because I've been programming all day, so it may take me a second to kind of wake up here. Sorry, it looks like it lost its connection when it went to sleep, so just give me half a second to get AirPlay connected again.
Just curious, who is this the first time for who? Okay, great. Sometimes a meetup is like twice this size. It's just like, it's interesting. It's kind of a more intimate environment than sometimes it's.
Okay. There we go. Okay, cool.
People are afraid of elevators or something.
Apparently.
There's also a human concept, which is an noise for traffic coming from.
Also, people hear distributed systems and might get scared off.
Keep that in mind. Okay, yeah. Project is called Secure Scuttlebutt that I'm going to be talking about today. This is a project created by a guy named Dominique Tarr, who lives in New Zealand currently on a sailboat. He started it in summer of 2014. During that summer, I was actually messing around with WebRTC personally. I was trying out different ideas for peer-to-peer systems and wasn't super satisfied with any of them. So I had known Dominique a little bit through the kind of internet grapevine, and so one day I asked him what he was working on because I was completely unhappy with my stuff. And he told me about this project, and I pretty immediately said, I think this is a really great idea and I want to get involved. So I joined in August of 2014, and I've been working on it with him pretty consistently ever since then. Okay. This is the problem definition that we picked out for ourselves. Web services are not free and open source. The web uses a whole lot of open source software on it. You use things like Nginx, Redis, Postgre, things like that in the back end. You use a whole lot of open source software at the front end, things like frameworks and libraries. But the services themselves are closed and proprietary. You're not able to audit the source code services that you use. You're not able to access your data in its raw form. You're not able to push code to a web service, right? They are completely closed and proprietary, and this is just inherent in the software as a service model. You could say, well, everybody is free to start their own server, so why not just self-host? The problem with that is that user accounts are tied to the deployments themselves. So even if you were to create your own Facebook clone, which was wildly successful, stole everybody off of Facebook onto your new service, you'd pretty much wind up with a meet the new boss, same as the old boss problem, right? It wouldn't change anything. Everybody would just be on a new service. So that puts you in a little bit of a Lord of the Flies kind of situation, right? Somebody's holding the conch shell, and everybody else is kind of taking the back seat to let them make all the decisions about what that service is going to do. I think the result of this is that we're going to lose. Right? We lose chances to make tweaks to the software, to try out new things, to innovate on the software. We lose the opportunity to set policies around who gets access to our data, whether or not things are like end-to-end encryption are going to be used. We lose the opportunity to enforce that. We don't have an opportunity to decide how to deal with trolls or spam, or whether or not we have to give our real name or our real gender, or whatever you feel about your gender. So we lose the opportunity to police ourselves as a community. Yeah?
Question on that. So part of the reason why Facebook is successful is because of the data mining that they can do. I think that's part of their value, right? So if there is a solution where everybody has access to that, does that mean, is Facebook valuable?
Well, so is it valuable to the users because of the data mining?
Users versus, let's say owners.
Well, then I would say that that's a misalignment of value, right? It's like if...
No, I disagree, because I think that every software that gets created, I think somebody thinks they're going to make money in it.
So, well, that defeats the whole purpose of open source software, though, doesn't it?
Well, I have no problem with people making money with open source software if not. But I think that the primary owner of their software should be the user themselves, right?
Yeah, that's where I was kind of going.
Okay. Yeah, and in particular, I would just say that who gets to make the decisions about the software? And that's what bothers me now, because I would say we have minority control, right? And I want to have the self-policing, the self-determination for this kind of stuff. Okay, so if we take that as our problem definition, let's look at some of the basics of how we might be able to solve this. This is a quote by Linus Torvalds that he gave when he was talking about Git in an interview that he gave not too long ago. I'm just going to read it for everybody. The big thing about distributed source control is that it makes one of the main issues with SCMs go away, the politics around who can make changes. BitKeeper showed that you can avoid that by just giving everybody their own source repository. What he means by the politics around who can make changes is sort of interesting. If you don't have a distributed source control, you have a hosted one, like SVN. When you make a commit on SVN, you have to actually open up a connection to the host of the repository and negotiate the commit there. So if you're going to do that, then you actually have to have an account on that host, and you have to have read and write permissions, and you have to be ready to take up resources, and so on and so forth. So for a project that's as big as Linux, it probably is not tenable to be able to freely create accounts and deal with that. And so you enter into a political problem. Who gets to have an account in the Linux Foundation repository? Git solved that by basically saying everybody can clone the repo into their local device and work pretty freely. There's no one host that runs the thing. They'll have official copies somewhere, but you could make a clone without a whole lot of barrier to entry, make changes, and then synchronize it with anybody else that you like. So there's no one organization that has a tight hold over any project that's run on Git. Okay, so that sounds kind of like what we want to do, right? The problem we have with web services is politics around who can make changes. So perhaps we can have distributed web services in the same way we have distributed source control and give everybody their own deployment. And this is the idea behind Secure Scuttlebutt. It's a distributed data publishing service. Basically, everybody has a copy of the deployment on their own device, and it synchronizes in a pure mesh. The service itself behaves more or less like Twitter, but kind of with raw JSON. And then we can take away the conch shell and let everybody have their own little home. Okay, so really basic overview of how it works. 3 things you got to know. One is that users publish JSON feeds The feeds are followed socially, like on Twitter. Synchronization occurs in the background. Okay, these are the three things, the three major points that you just kind of have to stick in your head if you're thinking what a secure Scuttlebutt does. These are the 3 points. So these JSON feeds are fairly free form. You can put anything you want in these objects. There's no restriction on the schema. The only real limitation is size of the message, and we're still talking about right now what it should be. It was a 1 kilobyte limit for a long time, and we're expanding it now probably to 8 kilobytes. I would even like to go to 15, but it's one of those things where it's easier to expand than it is to contract, so we're kind of taking our time deciding what that limit's going to be.
Does that kind of go along with the size of a standard TCP packet or an Ethernet frame? Was why you started with like 1,000, because your TUs are going to be a lot larger than that?
That was actually the original idea. But then we found that the headers were 300 bytes. So you automatically lost 30% of the message right there. And then we also have a linking format, which is somewhere around 50 bytes. And that all adds up real quickly. It was like, well, let's go ahead and just loosen things up, because it's more important to have the developers have a good experience working with the feed than to worry about the efficiency of the individual.
Versus having leaky abstraction.
Yeah. Right, JSON feeds, pretty straightforward. The feeds, each feed represents a user in the network, and you follow them socially. You can think of it a lot like Twitter or like RSS. That means it's a pull-based network as opposed to a push-based. So that would be like in opposition to email, right? Email is push-based. You can send an email to anybody, and we felt that was not any good because a lot of people can't self-host email because spam is such a huge problem. And so with a pull-based system, you can actually choose who's going to spam you. Okay, then synchronization occurs in the background. This is done with the gossip protocol. This occurs over the LAN or over the internet. In the case of the LAN, we have a multicast UDP that we use to discover other peers that are running on the local network. If it's on the
again? I'm sorry.
If it's on the LAN, we use multicast UDP to discover people.
So like Bonjour or something like that?
Yeah, basically, yeah.
Okay.
If it's on the internet, we use something called pub nodes, which I'll explain in half a second. Now, gossip protocols are fairly, I would describe them as highly cached protocols. The basic idea is that the nodes are able to rehost messages for one another. So I have a little diagram to go off of here. If Alice and Bob decide to synchronize with one another, Alice sends her current feed state over to Bob, and now Bob is caught up on Alice. Then Carla and Bob decide to synchronize, and Carla is actually interested, she follows Alice. So she also asks Bob, do you have Alice's feed? And Bob says, yeah, actually I do, I have the most recent. And so he sends Carla her messages, right? So this creates what you call a transitive connection between them. Even though a direct connection was not created between Carla and Alice, they're able to communicate with one another through Bob. And that's a pretty important property for this network because it's actually hard to create direct connections between user devices because of network address translation, because of firewalls on home networks and on office networks. So the gossip protocol deals with that problem with transitive connections. And that's where the pub nodes come in. These are public users. They're not special. They don't have any software that differs from anybody else. They don't have any special authority. They're just reachable at a static IP, or they might have a DNS entry. They're probably just bots. So in this scenario, Bob would probably be a pub server, right? And he follows Alice and he follows Carla, and Alice and Carla are able to connect to him and sync with him and transitively sync with one another. The other nice thing about the bots is that user devices tend to go down pretty frequently. You'll turn off your computer. The bots stay up all the time, and so they provide a high overall availability for the network. And even if one bot were to go down, you should actually have quite a few of them. So you're synchronizing with a lot of these pubs at once, and one goes down, the network stays active. So that's the basic fundamental overview. And those 3 points, you publish JSON feeds, you follow the feed socially, synchronization occurs in the background. That's pretty much all there is to know about it. One point I wanted to mention about the sync, the service lives on your device itself, right? Everybody installs a copy of the SSB software. And so whenever you are doing anything with the feed, when you're reading the feeds, whenever you're adding a message, you're actually talking to your local device. Then you add a message to your feed, that'll synchronize later on, right? That's kind of handy because you have no network latency, right? And your device is completely dedicated just to you. So there's no problem with resource sharing whenever you're working on your application. This cat's blown away by how cool this is.
Quick question. So like at that point, the data set that you have on your disk is essentially data you're only concerned with, and it's just could be a huge data set, and you're sort of just like caching the internet and social interactions that you're having with other feeds in such a way that it's only the information you're interested in at any given time. And that's pretty useful for like offline access, I'd say.
Yeah.
You can't just be like browsing the internet and you're interested in some piece of data and you publish it to Twitter, and then suddenly you have that offline as well. So that's interesting. Very, very cool.
Yeah.
That's not really a question. It's more of a whoa, dude.
Offline access is pretty seamless.
Actually, going on that, how do you limit? You set your own limits on how much data you store? Because as soon as you say you're downloading the internet, I'm like, okay, I'm downloading the internet.
Yeah.
Right. I've got my piece of hard drive.
Come on.
Yeah, but still, even that is like the data you're interested in. Is that dealt with in secure Scuttlebutt, or is that is that for the application to decide?
Yeah, we can talk about that more actually towards the end. But you do have a question of unbounded growth that you have to address at some point. We don't have a garbage collection scheme built in yet. It's kind of one of our open questions, so we'll deal with that in a second. Okay. Right. So we have the basic idea out there, but now we need to talk about how this works without any central coordination. If there's not going to be one person in charge of things, what is the protocol doing to allow that to happen? And so there are 3 guarantees that I'm going to talk about briefly that more or less cover that. The first is that we have provable authorship. Second is the notion of monotonic progress in all the feeds. And the third is that history is immutable. History cannot be changed. And the second and third one actually relate to each other pretty closely. It's provable authorship. All feeds, when you create a feed, you generate a key pair for the feed. On the first message, which we call the init message, you publish the public key. And then all messages that you publish are signed by the private key. Right? So somebody receiving messages from a user, you'll get the public key in the first message that they send out, and then all those messages, you're going to check the signature against the public key. If you get a message and it doesn't check out against the signature and the public key don't check out, you just reject the message. Right? That's a sign that maybe that peer is trying to send you a forgery. And that's pretty straightforward asymmetric cryptography. The second guarantee that we have is monotonic progress. Monotonic is just a fancy word really for saying that it's always ever going to grow, never shrinks. So there's only one thing you can do to the feed, you can just add to it. Another kind of common word for this is an append-only log. There are 2 points of value that we get out of this. The first is that it makes replication fairly efficient. Second is that it helps keep our network consistent. Efficiencies comes from the fact that whenever you have, let's say you have 10 messages from somebody and you want to find out if they have any more messages that you need to get. Say, Bob, to have any new data that I need. Well, you send over to a peer, all you have to do is send, I have 10 messages from Bob. Does Bob have anything else? And that peer will say, actually, yes, he has 15 messages now, so here's 11 through 15. Right? So you just send the feed ID and last message sequence number in your local cache, and then you automatically get whatever's due. right? So it's a relatively lightweight synchronization handshake. As for consistency, if data is immutable, then once it's been sent out, you don't have to worry about it changing at some point. So you don't have to worry about staleness, right? If you have message 10 from Bob, then you know that's message 10 from Bob. You never have to worry that it's going to change in the future. And so that's fairly useful when there's no single authority, right? It's a guarantee that we really need to have.
And delete.
No delete either. We'll talk about that. So complementary to this is the notion that history simply can't be changed. We have to actually come up with a way to make sure it's impossible to do. And this is one of the kind of more interesting and nuanced parts of this. Basically what we do is we have, if you just look at this side over here, and I know this is kind of low, so I'm going to move this. If you just focus on the A column here, this is a feed, message 1, message 2, message 3, message 4, and so on. Every message includes a reference to the previous message, okay? And these references are content hashes, which you could also call a checksum. And I hope a lot of you guys are familiar with the checksum already with the content hash. But basically it's a number which you can generate from a piece of content, from a piece of data independently. And if two people were to do it on the same piece of data, they'll both get the same number. And so it's a way to basically check the integrity of the information, right? So what will happen is that you have this chain of previous references here. When replication occurs, when you receive a new message, you check that hash and you make sure that that prev hash agrees with the message, the most recent message. So let's say you get message 5 and you say, okay, well, message is referring to 4 here. Message 5 refers to 4. You check that hash, and if it does not agree with the previous message, you discard this new message. Okay. The idea here is that if you try to alter the history, the hashes are going to stop agreeing, and you're not going to get gossip. Right? We call this forking. Say you go along, you have 5 messages, and somewhere along the way you decide to change number 3. So now you have basically forked your history. You've created a branch in it. And so now there are 2 timelines for you. This is an error condition in the network, and we're designing this to avoid this, to stop this from happening. So it's kind of interesting how this works. It's subtle, so let's just go through some examples. You put out messages 1 through 5. You decide you want to change number 3. So you go ahead and do that. Now, let's say it's Bob that has done this, and Bob and Alice synchronized with dataset A, with history A. Now Bob wants to change his history. It's too late. He's already talked to Alice, so he can't do anything about that. But now he talks to Carla, and he figures, well, at least I can change it for Carla. So he changes message 3, sends that over to her. 1 will work fine, 2 will work fine, 3 will work fine, but then 4, he'll actually have sent this 3 over here. So when he gets to 4, 4's prev hash will refer to this, not to this, right? So Carla will say, whoa, your 4 is wrong. I have to select for this. That's what Carla will say. And so Carla will reject 4, right? So Bob's not stupid. He says, okay, well, I'm going to go ahead and recompute all the hashes and fulfill the rest of this timeline. So then he talks to Carla again, and he sends 1, 2, 3 prime, 4 prime, 5 prime. This time Carla accepts it. She has no reason not to. All right. Problem is that eventually Carla and Alice may talk to one another directly, or Carla may talk to Dan up here, and Dan may talk to Alice, or something like that, and eventually they're going to notice that these prev hashes don't agree, and so he's going to be caught out. On top of that, he is going to have to, were he to try to do this, he would also have to maintain 2 histories for everybody that he's ever talked to. For Alice, he would have to be appending to this history, and for Carla, he would have to append to this history, right? And it's not really knowable who has what history for you. So it's relatively trivial to detect if somebody is changing their history. And even if they are able to really carefully separate the network, you would assumably this is a global network and everybody's going to be able to reach everybody eventually. And so at some point you can start to gossip each other the checksums to see if history has changed in some way and detect if somebody's being duplicitous. And
question.
Yeah.
And because they're signed with Bob's key pair, then nobody else can discredit Bob because
Right.
Bob signs them.
Bob signs all the messages. So the only person that could be trying to alter the history if the signatures check out is either Bob or somebody that's compromised Bob's key pair. So and no matter what, it either means that the user that's themselves is acting incorrectly or their key pair has been compromised. So it's a sign of feed corruption, and you pretty much immediately want to broadcast that and discard that feed. And it's just, it's not something that we can always 100% catch, but it's one of those things that's we want to make so hard to get away with that you have a strong disincentive to ever try it. Because if you do so, your feed could be completely wiped out of the network.
So why? Why do you want to make sure that doesn't
Well,
like, I'm just trying to think of a real world scenario, like, or,
Yeah.
you know, like, people that are utilizing this, what are you trying to stop?
well, like one example would be, this is kind of a fun example, but let's say you put out your location and your message or whatever, let's just go with that. And at one point, somebody connects to you that you happen to know works for the IRS in Texas. And they're like, all right, you live in Texas, and you send them a thing saying, oh, I live in Massachusetts, right? You don't want people to be able to get different versions of the state if you want everybody to be able to think of the data set as being one unified data set, right? So if people can start telling different things to different people, this wouldn't be one network, right? And that's kind of the main idea, is that everybody's supposed to have the same data set. It's supposed to be a global service.
Maybe another example based on the last talk that I saw you
Yeah.
give is like a Google Docs, right?
Yeah.
If you're doing multiple edits and one person is forging edits that shouldn't be possible by changing a letter that doesn't actually exist in the source feed, right? And then republishes messages. Now you have a conflicting state that you would have to resolve in your doc, right?
Yeah.
It may not be malicious either. Like
Right.
maybe you like have a Windows update and it fucks up, and now your feed's totally screwed for some reason.
Right.
You're publishing all kinds of crazy data, and the network's going, don't listen to this dude. He's on drugs. He's on that Windows update. So like, it also just protects against general bad software.
Right. Right.
I had another question. The content hash, does it also include metadata, or is it strictly that JSON payload?
It includes, it is the hash of the entire previous message. So the envelope, like the headers in the thing, it includes that as well.
Does it also include the hash of the previous message?
Yes.
So it is like a commutative history like Git does.
Yes. Yes.
Like one hash can never have it. Even if you change something way back, it will still be able to detect it, basically.
Yeah, like so if you were to change message 1, you would have to recompute the hashes for every message sequentially, because each one would change.
Right.
So you can kind of think of the prep hash as a rolling hash is another similar word for it. And it means that you could check the hash of the last message and know if history has changed at any point in the past.
Yeah, that's what I was thinking. Okay.
Yeah. Yeah.
Yeah, it's kind of an extension of the question I was asked before, but like if Carla gets her data from Bob, and then Dan gets his data from Carla, and then Dan and Alice talk to each other, but Bob has like modified his payload before sending it to Carla, then how does the system know whether, I guess, Alice's or Dan's data is incorrect? Is that because like
Who done it kind of thing?
Yeah, and is that like the signing? Is that's
The signing,
against
yeah.
that? Okay.
It always, the whodunit always has to be the key pair holder.
Okay.
Right. So again, it was either Bob or somebody that stole Bob's key pair.
So the system basically doesn't care like who corrupted it, just like let's just drop this.
Corrupt is corrupt in that scenario. Yeah.
Cool.
Wait, so it would drop both, is what you're saying?
Well, it would basically be like, well, Bob's feed is screwed. What are the
Right,
messages
right.
on there? And at that point, you have to be like, well, were any messages valid? You know, you've called the whole feed into question at this point. You could evaluate. You could
Yeah,
try
so
to
the
figure
idea
it
would be
out.
you'd have to go back to Bob and then decide whether you trust Bob anymore at all.
Well, you'd probably want to consider that feed to be dead. You probably ask that user to create a new feed.
Right.
Yeah. That makes sense?
I think there might be a little bit of an issue with people being duplicitous. If I want to screw you over, I can just mimic your feed, publish a whole bunch of data, you know.
You need to steal my key pair.
I guess it needs to key, right?
Yeah.
Yeah, cool.
And hopefully, if like something legitimate went wrong, there's enough replication going on where like if you needed to make a new feed, it's not that big of a deal because other sources have it.
Yeah, you can, I mean, the recovery mode is Bob creates a new keeper and then goes through the feed that everybody else discards and we publish it as again themselves and then you reestablish trust and the history is reestablished kind of, right?
Yeah, pretty much.
Like
Problem I was
retroactively
seeing
just, here's everything with new feed, new key.
Yeah.
Yeah, so the point is that
timestamps would change, but
nobody
that's
can
about it.
pretend to be Bob and
No, you
nobody
can actually
Bob,
forge
Bob
timestamps.
would only be
There's nothing-
responsible for doing it
Right.
himself,
So,
because he signed it.
cool. Anybody else have a question about that? Because I know this is a complicated piece to explain here. Good? Okay, let's keep moving. Yeah, it's my favorite. Okay, so that's our overview and our protocol guarantees. The one last section that I'll cover here for the kind of formal main part of the talk is the conventions. I call them conventions because you don't have to follow this for the system to work. You could completely ignore these, but you probably wouldn't want to. They're pretty useful. And they all have to do with the content of the message. The first is that the messages have a type attribute. This is just a string. The only effect that it has is that the SSV software indexes on this value. So you can say, give me all messages of type post, or type profile, or type event, things like that. So it's kind of a convenient way to fetch messages. In practice, the applications use it conventionally to do things like to set a semantic for the message and to possibly even set some of the schema. So we have, for instance, a post type, and that's kind of formally recognized as it's going to have a text attribute. The text is the content of the post, right? We're leaving the schema determinations up to the application level. So the protocol itself doesn't necessarily decide. So this is a really informal, basic approach to that. The other convention that we have is links. And links use content hashes as well. We have three types of links that we put in the messages. Links to feeds, links to other messages, and links to blobs, which is just like files. So respectively, if you're linking to a feed, you have the content hash of the feed's public key. If you're linking to a message, you use the content hash of the message. If you link to a blob, you're using the content hash of the blob. We're really big fans of content hashes, if you kind of started to pick up on, because again, they have an integrity check inherently, right? Once the actual data comes in, you can recompute the hash and make sure that what you were looking for is what you got. Right? And so that really helps whenever there's, again, no central authority involved. There's also an interesting property with messages. Two feeds going along. Let's forget our split history here. And look at two independent users. Let's say that's Alice and this is Bob. There's a very distinct order to these feeds within the feed, right? 5 is, of course, after 1. But between the feeds, there's no way to know which message came first. They're completely parallel in terms of their ordering. But what we can do is have message links between the two. And because they're content hashes, a content hash can only be created after the content itself is created. So it implies precedence, right? Message 3 on Bob's feed, if it references message 2 on Alice's feed, message 2 has to have happened on Alice's feed before Bob's thing. And that can even be true in this scenario, right? In which case it so happens that Alice had pushed 5 out before Bob put out his 3, right? Yeah.
What's the use case for these links? I guess I'm just having a little trouble wrapping my head around it.
One good one would be, let's say you are both working on a piece of information like a register, register foo, and you want to update the value. So Alice in message 2 sets the value to bar, well, I want to update the value to as. So I'm going to reference this message, which you set it to bar, and say I'm overriding that message, and I'm setting it to baz now. You see?
Okay.
Right. So that's how we can specify an order in the system.
So it's basically, it's like acknowledging a dependency, or
Yes, exactly. A dependency is exactly how I'm looking at it.
And our links application level definition?
So again, we create an index where you can say like, give me all the messages which link to this message.
Okay.
And that's basically all that we do.
So it's one message link per
You can
message?
every message can have any number of links
Okay, right.
to feeds, to whatever. And I'm not
But
going to
they're not named links or like,
name.
but you don't reference them by like, give me the name, the say you wanted to say this message is in response to this message, but it is, also references these other two messages. Which one is it in response to?
That is not determined by the protocol. It'd be up to the application to decide that. Yeah. Any other questions about the links? So that's pretty much everything. That's the full description I'm going to give tonight. Let me just do a quick demo of some of the software that runs on, so you can get a more clear idea of all this.
A quick question before you launch into that.
Yeah.
Is there a notion of privacy in any of this? Like if Alex is perfectly fine with talking with Bob, but really hates Carla,
Yeah.
can you keep Carla from getting the information you sent to Bob?
Yeah, I've got some slides about that in a second. So we'll hit that in just a second.
Encrypted with Carlos public.
Yeah, that's more or less what I'll say. There we go. Okay, this resolution is how good that looks. But yeah, so this is the application that actually ships with the software. It's sort of a Twitter clone. Yeah. Is that good?
Mm-hmm. It's good.
All right. So we decided to do something that's Twitter-like because it just fits the feed data model really closely. We have made a few kind of changes to the basic idea. We've got threaded conversations. Here we're talking about some memory leaks that we're dealing with right now. But this is sort of the basic interface for dealing with having conversations, being able to examine the state of the feeds, and also look at the individual users and kind of make reputation decisions about them, decide if you want to follow them or you want to trust them, and things like that. You can see who's following who and things like that. Now, if I jump over to the all data view, you can actually, in this view, see every single message that's on the feed, not just the conversations. So you can see, if there's an event like somebody making an upvote, it actually is going to be visible here. The upvote doesn't have any special rendering, so this is sort of just the content. This is very light, but you can see the type of this message is a vote. This right here is a link to the message that it's upvoting, and then here's the vote value of 1.
So the web service that delivered that vote to be viewable, like, is there a way to edit that?
To edit like the software that generated this message?
Well, is that not part of the web?
An application running on SSP.
Okay, so this is an application. This isn't what you did, or this is just an application running on the web service.
Yes.
Okay, got it.
Like this is a web service running on top of the protocol.
Right.
Well,
I think maybe
so
another way to say that, right?
it's like SSP is a distributed web service. Okay, so you can think of it as just like a web service, but in the same way that Git is a distributed source control, this is a distributed web service. So there's no single host, but practically you get the exact same results as if we were using Twitter or something like that. It's a system for publishing feeds of data between users. The topology is different. There's no central set of users that we have to route through. But SSB itself is a web service.
SSB, but what you are showing right now is an application built on top of SSB.
Yes, that is correct.
Right, okay,
Yeah.
I think that was
That was the question.
Client.
client,
An
yeah,
SSB client.
This is a client.
A client.
Is that okay to say?
That's-
We
that's-
had a different word for it.
That's yeah, that's fine.
Okay.
Yeah. This is that same message in its raw JSON form. You can see the content I was just pointing at right here. So the type and that vote topic link and actual vote value. And then surrounding it is the headers. So here you have the prev hash up at the top. You have the hash ID of the author. This is the sequence of the message. This is a timestamp, which is just used for convenience. We actually can't guarantee the timestamp, but in non-important situations, you can still use it. This is some metadata about what kind of hash is used. And then here's the signature verifying the authorship. That's what one of the messages looks like here. Now for just a quick comparison, this is another application written on top of SSB. This is just a GIF showing it. This is not a complete demo, but this is sort of a collaborative text editor that sort of behaves a little bit like Git in the sense that you make commits, and the commits are actually pushed to the feed. The content of the commit, the diffs, are pushed as files that are attached to the messages themselves, but then all the metadata about the changes are pushed as messages. And so you can see, I write something, I name the entire text buffer that I'm working on, then I name the commit there. And it generates that commit message. And then the kind of interesting thing about this one was that you could toggle in and out the commits in any order to let the different changes come in and out. I know Tristan, you'll be familiar with the logout CRDT. That's what this was built on.
Okay.
Maybe you're not. I don't know if anybody here is, but it's a kind of data structure which is meant to work well for this sort of thing, and that's what this was testing out. It actually did not work as perfectly as I like, but this still shows the basic flexibility of the data model.
So you kind of offload, you offload the work to the client. Say, do the Twitter example, for instance. If I'm following a million people, I just go answer that message a million times.
Say again.
You offload a lot of the processing to the client that's making the request. Say I'm doing a message and I want to notify all my followers. It would be its job to go and write all the followers.
To write all the
No,
followers.
it's a pull-based system. So the followers would come and say, hey, where are your messages?
Yeah. Yes. So, ask me the question again.
Like, the nice thing about Twitter is kind of real time, right? So when I say something, it kind of ends up in your feed.
Yeah.
But that work is significant given that it has to go and actually add that message to everybody's feed.
Oh, so the actual process you'll go through, there is a server that runs on your local device that we call Scuttlebutt. Okay, so Scuttlebutt runs on the actual user's device. You've written an application that connects to it with a WebSocket, interacts with it through an RPC API, right? So your application will add to the feed through that API. And then in the background, Scuttlebutt synchronizes with the pure mesh. So if you're Alice, your application is on Alice's device, right, communicating with her Scuttlebutt. It adds here, and then Alice is going to synchronize with Bob and send her updated feed to Bob. And Bob's a pub, and Bob is going to synchronize with Carla. And so Carla's going to get the same experience. Eventually, a message is just going to show up in her feed that came from Alice, right? So they're synchronizing.
So it's not client's work, it's a viral spread through the network.
Yeah. And that's what the gossip protocol does. That's like the commutative connection here. So you can, in reality, what you'll have is lots of nodes syncing with one another.
And so, but in this case, what really happened, correct me if I'm wrong, was that Carla said, hey, Bob, do you have Alice's messages? Bob said no. She may have done that 100 times. And then Alice publishes a message. Bob, in the meantime, has a process that's running that says, hey, check if Alice has any new messages.
Yeah.
He has to get the message from her and request the message. She doesn't push it to him.
Yeah, that's
Right.
correct. So the actual mechanics of it at the moment is that everybody basically has a table of peers, right?
They have to be like looping through effectively, constantly checking for updates.
They randomly loop through them. They have a small delay that they do, and they try to do so fairly randomly, but completely. They try to work their way through the list and check in with everybody. And they go through the replication handshake and say, okay, the last thing I had for Alice was message 10. You got anything after that? No? Okay. And then this time, yeah, you do. Great. Bring it down. Right.
So if Alice had 1 million followers, she's not going to get completely smashed with all follow, everybody wants their stuff.
So if she had a lot of followers, no. She'd get smashed if she followed a lot of people, right? Because then she'd be downloading a million feeds. You know what I mean? So every time she talked to somebody, her handshake would be a million hashes and their current sequence numbers, and then her actual replication would be downloading all the messages for those people.
Yeah, but if, like, say Alice decided she's, well,
So the load is like we're almost opposite of what.
Well, the only reason it's not so much load when she publishes is that the load gets distributed across the network pretty efficiently.
That's the
If she was the only one connected and she published 100 messages to her million followers and they all connected instantaneously, they'd all reach out to each other and go, no, 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 no. They'd all have to go to her, right?
That's assuming they all care about each other too. If all they ever cared about was
Was
Alice,
her, yeah,
then
Alice
is
would
screwed.
slam her.
Yeah.
Right, yeah.
But you know, the connections that occur for the gossip process are not related necessarily to the connection to the actual feeds themselves. Right? The two are abstracted away from one another.
Right, but they would suddenly be like, yes, I have data, and then they would have a longer lived connection to Alice, which would then probably like eat up her entire
Well, so if Alice is on like
her server can't accept any more connections.
if Alice is like, well, yeah, I suppose so. I mean, if Alice sends out to Bob, it would be maybe Bob who gets hit because Bob is now replicating out her things. Because in all likelihood, most users are not able to reach directly that many people. But the pubs can. And so if Alice sent like 1,000 new messages to Bob, and 100 people all asked for Alice's messages from Bob, then Bob would have 1,000 times 100, and let's say each one's a kilobyte each, and you can do the math on that.
And then the presumption would be that as soon as Bob's server is overloaded, Bob just says, no, I don't have it anymore. Or he says, don't connect to me, I'm offline.
You could
and they'll
go
go somewhere
down.
else to try to find the data.
Yeah,
The larger the network, the better, I'm guessing.
you might replicate it to another bot and say, hey.
yeah,
Yeah, right.
yeah.
So is this how I make money? Is I create a pub and pretty soon everybody just talks to my pub because I built a giant scalable service internally without a walled garden?
Will there be a GitHub to?
Yeah, so you can decentralize it in the centralized system.
Yeah, I mean, this is an extremely reliable.
Right. That's kind of like we don't know yet.
Yeah.
We're trying really hard not to do that, and seeing like what the limits of practicality are on that. But there's no thing with there's no interface served through the hosts in our case. So we kind of think that might be a differentiator because GitHub serves an interface to it. So maybe, I guess somebody could start to host people's feeds for them, in which case then something like that could happen.
Yeah.
I would say more likely this would end up being like torrent, where I'm going to just go out and buy a highly available seed box, right? And then it just springs up as, my seed box is not on my server, but it's not a central. You're not also using my seed box company, and he's not, right? Like, it seems like that lends itself more to like the torrent model,
Where you end up with something that's relatively centralized, where the edges don't deal with most of the traffic, but you end up with this core of replication dealing with it, but it's not a ridiculously centralized core, like a really high percentage of things going through a single provider.
Yeah. And something like one thing that you could end up doing is rehosting messages over HTTP. So let's say you have 1,000 users on your node, and maybe you just rehost their messages for people to browse through. You know what I mean? It's like that's something that people might want to do.
Yeah, so you could provide the interface.
Is there a concept
You
of
could-
order?
Order?
Like, say the follower example, I'm following 10 people, I go get their following messages. Is the network responsible for the client to put those in some type of timeline?
If the order is not important to the correctness of the data, then in scenarios like that, there are two things you can use. Every feed within itself has a very strict order, right? Sequence 5, sequence 6, sequence 7. And then between the feeds, everybody puts a timestamp on their messages. And you can't necessarily trust that, but if it's not important, usually you would expect that you trust your friends, right? The people that you're following. If they're putting out corrupting data, then you're going to want to not follow them anymore. So you can kind of trust the timestamps enough to say, like, if it's convenient and it's not going to potentially corrupt my system, I'll go ahead and believe the timestamp. Does that make sense? So that's, and then if you need something a little bit else, you also have the message links that you can use to get partial order from one message to another. Does that make sense?
Good question around this related to performance. So in the case of something like Twitter, where I guess timeliness of messages is fairly important,
Yeah.
is I guess the best way to tackle that would be to just put more pub nodes up, or is there a better way to do it than that?
Maybe, and also just making sure that we'll need to tune how frequently gossips happen. We may start to do things like continuous connections, where you just have like an open replication request, and then as soon as you get something, you just push the new message onto that open connection. You know what I mean? Like a live pull down.
Right.
Is something else we can do.
Like WebSockets or something along those lines, or?
Actually, it all works by WebSockets. That's every connection is WebSocket based.
Okay.
Yeah. Including the web applications.
What's the lookup for for a query, finding a message?
Well, we use LevelDB in a Node application, and then you'll have a WebSocket connection to. So Scuttlebutt has a LevelDB embedded. You create a WebSocket to that Scuttlebutt server, and you send a GET request to it, and then it's going to do GET by hash ID, which is like what it's stored the messages under. So it's a single lookup in LevelDB, and then any overhead that occurs for the WebSocket and the RPC protocol.
And then the hops.
Well, you're only going to be, the idea is you're only communicating with your own node, with your local device, right? You have a server running on your local computer, and you're going to be looking up against your local cache.
So you're basically assuming that like your information, well, each piece of item in your feed is basically a fact, right? I mean, it has information about like some data and a time, and that's really all you need to know. It's like this data at this time was this thing, and that's the way it's always going to be because there's no in-place updates, right? So I mean, you can pretty much just treat it as like this is the information that's available for everywhere. Obviously, you don't have to make that.
I don't think anything. So you have all the data locally. Is that your
All the data that you followed and that has been synced to you. You could think of it kind of like old school email. You know what I mean? Like before email was all hosted.
like files? You hosted your own email?
Either you hosted your own email or you use a POP3 server where
Yeah.
the server didn't keep your messages around.
Yeah, you would download it onto your local device, right? Though it's different than POP3 because the pubs would keep your messages around afterwards. But it's very similar to email in that regard, but kind of the biggest difference would be that we're pull-based instead of push-based, so we don't have the spam problem. That's the reason that we do that.
What about streaming? I mean, is this protocol pretty much limited to, one request, one message, and then it's over, or is it open to the idea of a constant stream of messages?
Yeah, we have. Let me have these that slideshow. We have a couple of different functions to create streams, like give me sequentially all the messages in Bob's feed, right? And so you'll pull them all down, they'll be emitted in some function one after the other for you to process them. And then you can also say, give me all of the feeds in one big stream and mix them together by their timestamps, right? Which is what is going on. Which is what was going on the demo there, on that application, right?
So if I committed, like, say I had a video stream, like HLS segments, and I wrote each segment as a entry, I could stream those segments effectively.
Like through a feed?
Yeah.
I suppose you could. You get crazy overhead if you were to do that. You know what I mean? Like, that would be, you have to have the headers on every message, and let's say we stuck with the 1 kilobyte message size limit. This is what you're suggesting, right? That you would encode a video stream on somebody's feed and then pull it, yeah.
Then you end up with worse than base 64 encoding overhead.
Yes, yeah, it would just be horribly inefficient. The protocol's not designed for that. Not saying you couldn't do it. And like the read time on your local node is really good. You know, you're not dealing with the high traffic volume, you're not dealing with network latency. So it's a WebSocket sending an RPC command over, making a level DB request against an index, and then pulling out, you know, sequentially from that level DB server. So embed. So it's really pretty fast.
So if I were writing an application
Yeah.
on top of Scuttlebutt, secure Scuttlebutt.
Yeah.
I'm interacting directly with this daemon effectively
Mhm.
running.
Mm-hmm. Yeah.
So is that a shared daemon across all applications I want to use secure Scuttlebutt on? Or does each one need its own instance?
It's shared. Yeah.
Okay.
One thing you could do is you could embed secure Scuttlebutt's libraries in your own application and run your own version of it, but you would also want to run your own feed in that application.
Right.
Right. So it'd be like creating a new user in the network for this one application. If that makes sense. Right. It'd be making a new feed for it. You don't want to have more than one application adding to a feed if it's possible that they could create conflicting messages, right? Because then you end up with the forked history. So you really want one process controlling the feed. And if you're going to have multiple processes, then you need to make sure there's a syncing protocol between those processes to make sure they never conflict with one another. They never both try to write at the same time, right? So it's simpler just to have one process be in control of the feed, right? So that's the reason for that.
So if I had two applications and I didn't want to give my data from the one application to the data of the other, like on accident or explicitly I need to for security reasons, how would I architect something like that?
You need two applications on the same computer that don't. I suppose you would need to. I don't know. Actually, I don't know if I can answer that. It's kind of hard to answer that question. You're wondering if you have two applications, you need to separate data between the two of them. In what way? Like what data?
Like say I wanted to make an application that synced all of my banking information between my devices, right? And I wanted to download that application, but I also was a blogger and I'm like blogging and that's like a public feed, but I don't want to ever accidentally have my, and then I want to download your application that does something else that you published open source that I'm just like, I want to run Paul's thing, it's kind of cool.
Yeah.
I'm going to run my node of that. I don't want my banking information to ever end up on my Twitter feed that's being published to you or my Twitter column or whatever, right? Like, that's kind of the situation that I was.
Yeah, I don't know if that's really in the scope of this project, because if you're installing those applications on your local device, it's not like we have any sandboxing technology here. Whether or not an application is able to post to your feed is basically based on whether or not it's able to authenticate with Scuttlebutt. And the way it does that currently is by reading the private key and signing a challenge. So we do it by the file system access controls.
Yeah.
And if you give an application access to the private key, then you make your choice.
Okay, so you just run two Scuttlebutts.
You could, yeah.
Effectively, with two separate users.
Yeah.
And you can imagine a content security policy where you're like, okay, this application has access to these type of feed posts, right?
Yeah, we've talked about that. We're not really sure what we're going to do. It's complicated.
It gets a little bit untenable because there's like there's like any number of feed post types, right?
Yeah.
So it's not like you can explicitly blacklist anything.
Yeah.
You could whitelist stuff.
Yeah, this is a big conversation that we've had for a while, and we've at the moment decided not to make any decisions. It's just too early. One thing we have talked about though is encryption. Oh gosh, is it gone? Yeah, it's gone. So we Dominic is currently working on the encryption story for us, and we are interested, ultimately, this is a key distribution is kind of inherent in the protocol. So we think that it'd be pretty neat to implement end-to-end encryption and make it a fairly straightforward thing to do that, where you can say this message is only meant for one person, and you use their public key to then encrypt it. And then we can extend that into creating groups of recipients as well. And we're just taking our time on that because obviously it's a nuanced thing. If we get it wrong, then that's kind of a black mark on the project. So that'll take some time, but that's one of the things that we're interested in. Something else that's sort of interesting is the web of trust aspect of this, which is sort of inherent to it. Again, you're distributing the public keys, and if we were doing PGP, you would have key signing parties. You'd go to their cert files and you'd sign off and say, I know this is who it is. In our case, what you would do is you publish on your feed a message linking to somebody else's feed saying, I know that's John and I know that's Wes, right? And I trust that person, or I'm flagging that person because I don't trust them, right? So you can basically publish any information you want about another key pair. So it's a really kind of rich web of trust model that we have, a lot of different signals that you can work with. And on top of that, you can publish updating information in the future. So maybe you trust somebody at one point, but their key pair is compromised. You're just going to publish another message saying that has happened. Their key pair has been compromised. Don't trust this person anymore. So you can revoke trust fairly simply in the system.
I have a question there.
Yeah.
So what if you say, I don't trust John, and then John all of a sudden says, I don't trust me? Who do the users believe?
That's up to them. I mean, the kind of, like maybe in a scenario like that, you would have, maybe there's a network of 10 people that are all trusting each other and 2 of the nodes do this. Maybe one of them is pretty clearly an imposter because everybody else trusts one of the 2 already. And so the other one would be like, yeah, probably that's the imposter.
But is that resolved by, who's that resolved by?
Who's the result that in the real world?
Yeah.
Well, yeah, I'm just wondering if it's an automated system that's taking care of it, or is it a UX?
It's kind of one of those, like the ultimate decider is going to be out of band. The ultimate decider is to call them up and start talking about what's your pub key. Okay, I think I have the right one for you. So, and you don't seem to be compromised, so it's probably this other guy. Things like that, right? And then in terms of like what you can actually automate, it's a complicated question. So in certain, it's hard to make decisions if you don't have total certainty. And so it's kind of an open question.
It's a merge conflict.
Sort of, I guess.
So it's out of band solution.
Out of band is like the final solution that we lean on. But also it's kind of like one of the things that I think application developers should toy with a lot, since like this is the model, like the trust is in the application layer now. It tends to be normally that you have CAs and they issue the certificates, and so everybody is all sharing the same one-tiered model of trust. But in this scenario, since it's a web of trust model, the applications can try new things in terms of what kind of signals they can rely on and what they think they can infer. So there might be some opportunities to try something new.
So can you go through the onboarding process of what a developer needs to do to get involved with building an application?
We are not really quite ready for that. Right now what I'm doing is I'm working really hard on getting the actual end user experience really good, and getting I'm actually working on onboarding into the network, making sure that's really polished. And then after that, I'm going to be shoring up all the documentation and kind of fixing some of the weirdness with the APIs. So I want to hopefully say somewhere like a month to 2 months that I can start telling developers to take a look at it and actually tell like new users to start getting involved. But right now where we're at is we have about 20 people that I'm aware of using the software, and off and on, and about 4 or 5 of us using it just about daily. And
then there's that Friends project for chat.
oh yeah, sure. The Moose team. We kind of, they're in the same community as this project is, but we're not like directly involved with one another. But somewhat related to that, that's built on WebRTC, and we do actually plan to work WebRTC introducers into our network as well, so that you can use the pubs to create direct connections between each other.
I was reading their docs, and it sounded like they were actually switching over to SSB or something like that.
Oh, really?
Yeah, it's. I don't know.
Yeah. We'll stay in touch with them. We also sort of keep in touch with FOSS and the WebTorrent project to possibly do blob exchange. And then we also sort of keep in touch with the Interplanetary File System guys, if you've heard of them, the IPFS project, which is kind of a competitor to BitTorrent. And so we're kind of like sitting and seeing maybe which one we'd want to try using. So that's the situation with that.
So, correct me if I'm thinking about this in a wrong manner, but like, suppose you had any old database that can work in a distributed manner, where like each node could have read and writes, and eventually like all of them get synced up somehow, whatever mechanism that it is. So like, say you got Postgres, and if you had it set up to where you're like, hey, we've got this cluster of Postgres databases, and like all my friends are on it, basically. And like we just keep this repository of structured data all between us so that we can use Postgres and write our own applications on it. And it's not very good because Postgres isn't necessarily built for that sort of thing. But what you've essentially designed, or what you and Dominic have helped create, is this this database that like everybody can get in on, and it's structured data in such a way that it will eventually be consistent, and you do have like some sort of means of privacy and direct messages where you can hide information from other people.
It's more of a log though. So you could, I mean, heck, Postgres, I know MySQL does is they have the binary log. You could, in theory, transmit something like that over SSB and use that as the entry point for your database replication if you really felt like doing that.
Yeah, good. Yeah.
Is SSB your short for secure Scuttlebutt?
Yeah.
So I guess what I'm saying is just like this is basically a database that all your friends are on, and like you get on the database as if this were like the new internet kind of thing. It's the internet built on the internet, but it's a structured internet almost. And is that the wrong way to be thinking about it, or is it the right way? Like, is this database that you can connect to and then start writing applications on?
I do think it's right to kind of view it more in terms of the feed aspect of it. It is like a database, but kind of in the same way you could say like the web is a database that anybody could create a server on.
Sure.
So in that regard, it's similar.
But it's easier to program on.
Is there a scenario where I post my large application and say secure Scuttlebutt is the persistence layer?
The persistence layer.
So say I create something like Facebook and it's your shit all just goes to you.
So if you wanted to have an application that uses this, probably what you want is to be able to access the user's local version of SSB so that you can publish on their feed, through your application.
Well, yeah, my service that I'm building, I'm saying my cells like you're going to keep your data, and I'm effectively the pub node that connects you people together.
Would you want to provide an application interface that people use?
Yeah, it's an application that does whatever, something like Facebook.
So to do that, you would want to be able to, from your application, publish onto their feed, right?
You want users to be able to talk to each other.
Yeah, and we're kind of messing with that still. We actually had a scheme where you could have a website request authorization to publish to the local device, and then the front end would create a WebSocket to the local SBot, Scuttlebutt server, and then be able to post, right? But we took that away because we're generally uneasy about the security profile of web applications, because the code can change when it's posted, or on each request. So you could grant access once, and then in the future it could change on you. And we're trying to see if we can't wait until some other means of, like installed applications don't have that problem ideally, and so we're kind of waiting for that. We may end up reopening that API, but I'm not really sure.
So right now it would be like you run either a local server or like a node WebKit type deal, right?
Yeah.
Okay.
Yeah, it's all basically local device applications with the only things that can access it.
So it'd be like probably pretty optimal for like either mobile devices or, I mean, that seems like the best, right? It's like people are
mobile-
already used to downloading apps.
Yeah, I don't know. I know what you're saying. I don't know what it's like to make this work on mobile yet. I haven't looked into it yet, so I don't know.
I can do graph buckets just fine.
Yeah.
The machine's intensive.
So is it, what is the participating entity? That is, if I have an application and Alice is the user of the application,
Yeah.
is the entity Alice's, like my application feed for Alice, or is the entity Alice itself and my application has to get through? You know what I'm saying? Is
Yeah.
Alice identified as a person, or is an endpoint could be just my application, Alice's feed, and just that gets replicated. So all my other clients, they only care about my application speed and not all of the other Alice's garbage that I don't care about.
Yeah, this has been one of the really big topics that we've been talking about lately. One of the things we tried and messed around with was the idea of aliasing feeds to one another, so that you could say like, this is an independent feed, but this is actually Alice's, right? This is Alice's Tristan's app.
Right, yeah.
So that model could work, but it's just we need to understand the use case better before we can say, yes, that's what you can do, and yeah, that's how it's gonna work. So.
Because right now your layer is, your identifier on each feed is a key pair, and that's your single dimension.
Yes.
Seems like you could like nest one message inside of another or something too, to do something like that, right? Like you could say Tristan could publish a app public private key pair, and then the internals of Alice's feed, the content body would actually be the entirety of another Scuttlebutt message that was signed by Tristan's app.
Like a retweet, basically?
Effectively a retweet, yeah, that's what I was thinking literally in my head before I said this. I said, oh, you could do like a retweet.
I suppose you could, yeah.
Either that, or
Some sort of convention.
you also have the message types.
Yeah.
Yeah, that's what I was kind of thinking.
Yeah, that's kind of the alternative, right? That's why this has been a big conversation, is those are the two models
Well,
that have been.
But it'd still be Alice in the message.
Yeah, but the problem I'm addressing is, for example, if my application is chatty or whatever, it's the noisy neighbor problem, right? If everything has to be signed by prior, if my application is generating 100 messages per second or something stupid, and I'm doing denial of service against everybody else and every other application.
Even if that's like the correct operation for
Right.
the application, that could still be a problem.
Right.
Like if your application is supposed to generate thousands of messages all the time.
Right. Well, all the other messages get lost in the noise and people just can't receive it because I'm just flooding the app. Whereas if it's my own endpoint, you just never ask for it because you don't care about the app.
You don't care about that. Right.
Does
that make sense?
For, right?
Well,
So you couldn't like filter your reception of somebody's feed by type, right? In fact, right, you got to get them all because you need to be able to check this pref hash, the pref hash chain.
Oh, right, because the next one could be of a different type.
Yeah. We have kind of talked about maybe using a sort of tree structure on top of the pref hash structure that has the same effect but can tolerate holes. But that's
Seems like having one Scuttlebutt daemon that serves multiple users' feeds sounds like a better model for this, right?
Well,
It
and
may
what
be.
you can have is a design the application for you, whatever. But like the core Alice feed and its sole purpose, all its new messages is just the
announcing the sub
and announcing the sub feeds for different apps that sign up.
Yeah, there's also a good reason to do that because devices can't share key pairs, they can't share feeds. So if you have a mobile device and a desktop device, this is actually one of our largest complications right now. You can't like give the key pair to both devices and let them both post to the same feed because you might have conflicts that way. Right. So we need a way to alias feeds together in some way. And we have a PR that's basically sitting there that does exactly that. but nobody gets super excited about it because it just adds complexity to the model. Because identity is now you are now yourself as well as any subfeeds you create. So it's
I like that because that seems much more like the internet identity model than, because otherwise you're saying you're Facebook and you have to have your true identity.
Yeah, I mean, it probably, that's
You
not.
don't have to decide it right now.
Yeah, no, I mean, it's the model that I've advocated the whole time too. So, but it's just not decided yet, is all.
Yeah.
So.
One way to do it is to create a demo app that just spams and then they'll see the problem. Just put it on the network, like this sucks.
Best way to get
We wish
results.
we had a way to separate it out.
The best way to get results, legitimately.
I need to think about this spam bot.
I've also thinking about just taking everybody's feeds and then like creating new duplicates of their feeds and copying all their messages and seeing if I can't just create lots of fake identities for everybody just to mess with them.
You need extremely important messages with your noise. You would have missed this.
Yeah, right. Like, get them locked in like on really important messages, and then suddenly start spamming them all.
Yeah, put in like Bitcoin wallet addresses for like,
They gotta filter out the noise.
Have you ever considered selling the feed just to advertisers that make some good money?
Oh, what do you mean?
I'm just kidding.
You're just joking.
He's trolling.
Yeah.
Got it. I'm all about the cash out.
It's really about collecting people's data.
Yeah.
And selling it to somebody who's too stupid to set up their own node.
Yes, exactly.
Scuttle mail.
Ooh.
Scuttle now.
Just giant
Sounds kind of
efficient pub server.
Where did you guys come up with the name, too, by the way?
Dominique came up with it, and we had this giant issue that went on for months where we tried to come up with new names, and it turned into like the biggest bike shedding event I think in my life.
But like, well, gossip is like a real. Well, it's outside of this project, right? And Scuttlebutt is like it's like a derivative of gossip.
Yeah, Scuttlebutt is a key value gossiping protocol that Dominique implemented that white paper, the Scuttlebutt white paper, and then afterwards he was like, hey, I could make another version of it that adds these features into it. And the funny thing is that like the final version of like the secure Scuttlebutt protocol does not really resemble the original Scuttlebutt protocol in any really like you kind of have to squint to see the semblance. So it's kind of like but that's what we got now.
Yeah, I didn't know until I met until this project that Scuttlebutt was even a word, and it was a synonym for gossip, I believe.
Yes.
Well, the original was a tiny ship or something.
Oh,
It is a nautical term.
Yeah, it's nautical. Just like
Go
a packet.
It would go from ship to ship.
I learned the other day that packet was also a nautical term. It was a mail boat that carried mail through harbors.
Like most computer science is nautical terms. It's crazy.
Yeah. That blew my mind when I learned that. If you just go to Google, define packet, it'll give you the nautical term.
nice.
All right, well, let's hear from Paul.
Thanks, guys. Thank you very much.
It was a really healthy Q&A session, so I appreciate that. Just real quick, let's kind of go around the room. We don't have a ton of time left, but since there's so few of us, I think it's a great time to get everyone to know each other. Let's start over here with someone I probably should introduce at the beginning. This is Daemon. He's one of the co-host organizers of the event.
Daemon Skills. I trade guys at a textbook company called Vital Source. I'm a remote worker there in North Carolina. And I've been doing that for quite a while, and so wanted to help create this community with Jason and Keith and more on.
My name is Howard Rauscher. I'm Director of Engineering at Spreadfast. I used to work for Mass Relevance, and when we merged with Spreadfast, a lot of my work has been focused on is how do you do cross-product integration, so it's a lot of internal APIs, so creating the platform for that.
My name's Troy, API Product Manager at UShip, where Jason used to be for quite some time. Yeah, that's about it.
I'm Jake Wolke, work at UShip as an API developer, worked under Jason and Troy, and been to quite a few of these.
My name is Tristan Slominski. I work at Bazaar Voice right now. API related. I've created a capability sharing service that it works now. I'm just writing documentation before I share it.
My name is Ian Levin. I work at a company that probably the app that you might actually know about is Parking Mobility. I run the back end, which is all API driven, and of course consume APIs day in, day out. And the only side projects that I've kept around are all API based.
I think we have
What do you do again?
So yeah, I'm Eric. I'm relatively new to Austin. I've been here a couple of months. Most recently was a software architect, business insider. I do PHP and JavaScript development. Looking for positions right now, both contracting and full time. So any of you guys are looking for people, I'd like to talk to you.
I'm John. We're looking for people. I'm CTO of Goodie Bag.
Oh, nice.
We make very private APIs that you're not allowed to use right now. But if you're clever enough, you can probably figure out how to do it.
Is that a challenge?
It's a really easy challenge.
He just told us they're on one server. We can take it down
No,
really easily.
Multiple servers. So yeah, CTO.com, we are hiring JavaScript folks that are interested in doing full stack work.
What does Goodie Bag do?
We provide food for offices. We actually do a lot of food for Capital Factory. So it's like, if you need food for groups, you just go online, order it, and it comes to you. And there's tools for companies and such.
Wes, principal front-end developer at stream.me. It's our new site, like 4 months. Our company pivoted. We were previously like video on demand, video hosting site. Now we're a live streaming site, similar to like Twitch or whatever. Yeah, I do front-end stuff. Consume a lot of APIs.
I work for the same company. I mostly systems and API work.
Do you have the same name?
What's your name?
Yeah, James. Also named like yeah, almost all. Everything's in Go. And
This guy who was over here gave me a message. Apparently his name is Corby.
Did he sign it with his key?
He did not. I'm not going to share it anyway. He works at a place called Clear Measure, and apparently they are hiring developers as well. I think he didn't say what specifically, but he says Angular is a plus, so I assume it's kind of front end related. On a similar note, UShip is always looking for talented developers, both front end and back end. We're a .NET shop with a smattering of frameworks on the front end. Always looking for people. Are there any other pitches for work that anyone would like to give? Nope. Okay.
While you're not hiring for the team on security.
As soon as I have lots of money.
Bazaar was inspiring, so lots of different places. Is anybody not hiring?
That's a fair point. Fair point. All right. I'm not sure exactly how long we have this room. Do you know, Damon? Is it till 9 or kind of till whenever? Yeah. Okay. Well.
6 minutes.
Yeah. Well, that's until 9.
Basically leave now.
I mean, hang out, drink a beer, have another one, whatever. Meet each other. Welcome.
What's your guys' schedule for this meetup?
I think now we're on the first Wednesday of every month. Is that the regular time now? We used to be a little bit different, but I think first Wednesday every month, right here for the foreseeable future.
And what are the topics usually?
Well, the topics range from a wide variety of things.
Obviously, yeah, but like
Obviously, right, and that can be pretty broad. We have lots of people come in and talk about lots of things. We have talked about documentation.
about specific implementations, about new technologies. It's really all over the place, and we're constantly looking for new speakers as well. So if you have something that you really are passionate about and looking to share, by all means, come get in contact with either myself or Damon, and we'll get you set up with the time, for sure. Otherwise, I think the new meetup on meetup.com should be up soonish, basically as soon as we find a speaker and nail him down, get his topic.
And the earlier we get in advance, the better. So you
Yeah.
get topics, send us.
Yeah, come to us.
But it is once a month, right?
Mhm. Every month. We haven't. I don't think we've skipped a beat in quite some time, if ever.
Okay.
Pretty regular. Well, yeah.